Ooh, there we go. I have an assignment for you today, so I'm going to run through a little bit of each so you guys are familiar with. Um, I think you guys prepped this for the Y-top, but I just want to make sure. So there's a sequence of problems or a collection of problems, and I want to run through and make sure you know how to do all the different types. So hopefully you can see. So I have it mixed up. There's 5 different types of problems. So the first type is which set of ordered pairs does not represent a function. And I think sometimes it might phrase it as which set of ordered pairs does. So just pay attention to the wording. In this case, we're looking for the one that does not. Do you guys remember what would make it not a function? Ah, there you go. Good. So to be a function, you can't have the same x producing different y's. So like if I look at the first problem, do you see how this first one has a 3? And again, if you can't see, you have to move because I don't want to go through all this again, right? So the first one has a 3 as an input and it gives an output of -5. For this to be a function, that same input, 3, can never produce a different output. So if you look later on down the line, here's the same input of 3 producing a different output of 1. So that means if it says which one does not represent a function, I would pick the first one. Yes?
Does it count still as a function?
Yeah, if you were to see the same exact point twice, it would still count as a function. I don't know that you will see that, but if you do, that's a great question. So again, the question is, can the same x produce the same y? So like, could I essentially see the exact same ordered pair twice? That would still be a function. Yes. Hi. So good on that one? All right, let's do another one. So this time it says which one represents a function. So again, you have to watch out for the words. So this time we're looking for the one that is a function. So can you see which one is okay? Yeah, the first one is fine because it's got all different inputs, -5, -4, 9, and 0.
It works. 80% of them are supposed to be hooked up and stupid.
So any questions on the first section? Okay, so that's that section. Let me go back and let's click on the second section. So this time we're trying to determine if a graph is a function. And do you guys remember what to look for when it's given to you as a graph? I see you doing up and down with your finger. What does that mean? Very good. The vertical line test. So remember, the idea is if you could take a vertical line and scan it across the graph, if it's a function, that line will never hit the graph twice at the same time. And this is obviously not a function because you can see there's lots of points that are above and below each other. So this one would certainly be not a function. Right? So they do a good job of animating this. You can tell that the people that wrote this are math teachers because that's exactly what I want you to see it as. So that vertical line, you see how it's hitting, like constantly hitting the graph twice. Let's do another one. How about this one? Function? Again, very much not a function because it's going to, when you watch the line go across, it's going to constantly be hitting the graph twice. It does neat. Yeah, it's a neat graph, right? That's a rational function. That's kind of the same thing. How about this one? Is this a function?
Yeah.
It is very good. So we can say yes. And again, if you watch the line go across, which I presume that it will, you see how it never is hitting the graph twice. And there's that one part where it's like between the two arms of the graph, but it still never actually hits them both at the same time. So yeah, that one's definitely a function. So any questions on that section? Okay. The third section is evaluating a function from a graph. So what they're asking us for is f of 7, and this is the graph f of x. Do you guys remember how to find a function value from a graph? So 7 in this case is what we would call the input. Let me get my writing utensil up here. So the input of the graph is right there. I'm pointing to it up there with that little red arrow. So that's always going to be an X value. That's what's an independent or an input value. So I'm going to go to 7 on the X axis and I'm going to make a mark right here. And you can clearly see that the graph is above me when I stand on the axis at 7. So if I look up, 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 the question is how far up do I have to go before I strike the graph? And what is the answer? 5. It is right here and it is 5. So that's all I have to do then is go in the little box and just type in 5. They're just asking me for an output value at a given input value. All right, let's do another one. How about this one? It says, what's the function value at -3? -3 is the input, so where do I go? Left 3, yes, you guys have a lot of words today, using lots of hand gestures. Speaking must be at a premium today. So there's -3. So I'm going to go left 3, and the graph clearly exists below me. So I'm going to go down 1, 2, 3, 4, 5. And you can see I strike the graph right there at -6. So that's all I have to do is type that in, just -6. All right, let me see if there's anywhere there's multiple possibilities. These are all pretty straightforward, I think. Yep. So you shouldn't have any issues with that. The next section is evaluating a function, but this specifically is a linear function. That means that you won't have any x squareds or x to the thirds or anything like that. Linear just means x to the first. That means that if you were to graph it, it would be linear, a line, of course. So how do I evaluate f of -5? You guys remember this one? Again, this number is called an input. So that means that I have to go to my function rule. I'm going to put a purple box around it. That's called the functions rule. And I'm going to take -5 and I'm going to put it right there in place of x. And then you just have to do a little bit of baby kitty math, right? Easy peasy. What's 2 times -5? And then -10 plus 1 is -9. So I just go in the box and I type in -9. Submit it, full send, easy peasy. Is there anything? Let's see if we can find anything more difficult here. How about this one? It would just be 3. Very good. And again, the number that it says h of or j of or f of, whatever, the number in parentheses is just the input that you change your variable into and then follow the function rule. So this one you just do 0, of course, plus 3. Easy. How about this one? Yeah, easy peasy. Put -3 in place of x. -5 times -3 is +15 plus 1 is +16. So nothing to it. And then, of course, the last one that I have for you is evaluating quadratic functions. And so these are harder, but still not difficult. So the way this is going to look, remember, the function rule is the math that comes after the equal sign. So what's in that purple box is what like the law of the land is for this particular problem. So in this problem, I'm going to do 2 input squared minus input minus 12. I feel like these are a little harder. They just at least require a little bit more effort. There are stupid mistakes to be made. So let's try to coach those out of you real quick. I'm going to put 8 as my input. So I'm going to put 8 right here and right here. And in that first section, let me draw a little green shape around it for you. In this section right here, what do you do first? No. So you can't, we're not solving an equation here, so you can't. You should want to put 2 and 8 together, and that's not right. But that's why I wanted to do this with you, is because the order of operations, remember, demands that exponents go before multiplication and division. Remember that? And so even though the 2 and 8, like you see them first, you have to fight that urge. And the thing you have to do first is what's in this little purple cloud here. All right, so you have to do 8 squared, which is, there you go. So we're going to wind up doing 2 times 64 minus, and I don't need parentheses around that, 8 minus 12. What's 2 times 64? 128. What's 128 minus 8? And what's 120 minus 12? 108. And that's that. You see, those are going to take a little bit more effort on your part, but that doesn't mean they're difficult. It just means they're relatively more difficult than their predecessors. Let's do another one. So this one, again, the function rule is what's in my purple box. That is the law of this particular land. And it says to do -4 times input squared minus 11. And my input is -6. And you shouldn't need a calculator for a lot of this, but I just wanted to tell you that if you do use a calculator, make sure you're aware of the fact that your calculator will always do exactly what you tell it to do, not necessarily what you want it to do. So if I were to put a little itty bitty, like a green bubble cloud around this, you guys know what that equals? It does. And listen, again, you're in high school. There's no way you should be using a calculator for -6 squared. Sorry, if you don't want to hear that, too bad. You're in high school. But if you do type it in incorrectly, if you type this into your calculator, do you guys know what it will give you? Try it. Get your calculators out and try. Just type in exactly what I put on the TV. And you know, again, because you're in high school, that -6 squared equals +36. Your calculator says -36. Try it. Take it for a spin. Type in negative and then hit 6 and then hit squared. Why does it do that? Do you know?
Because the square on
You're on a roll today. It's exactly what it does. And again, I say again, the calculator will 100% of the time do exactly what you tell it to do, but it cannot read your mind. And like Kyla said, if you type in -6 squared like a knucklehead, it's going to do exactly that. It's going to do the exponent first. And what is 6 squared? It is. And then it's going to make it negative, as Kyla said. You have to either A, understand that it's going to come out positive and just don't type in the dang negative in the first place like a knucklehead, or if you absolutely are hell-bent on using your calculator and typing it in perfectly, then at least type it in -6 with parentheses. If you type that in, now your calculator will tell you what you meant for it to do. Okay, and we've talked about this before. When we started the quadratic formula, the first thing you see inside the square root sign is b squared. And that's that same idea where no matter whether b is positive or negative, we know it's coming out positive. So don't let your calculator bully you into saying something stupid, right? So anyhow, if I take this -6 and I square it and I get 36, my problem now looks like this: -4 times +36 minus 11. And what is -4 times +36?
-140.
Minus 11 is,
100.
there you go. Good basics. You all right there, Tegan? Oh, and that's really that. I don't think necessarily that there's anything else that could trip you up. There was one more thing that I was looking for. Yes, it's this. So I wanted to do this one with you, and then I'm done. And the rest of the hour, you could just get this assignment done. The Delta Math's prediction is that this assignment will take 2 hours and 30 minutes. It could not be more off the mark. There's no way this assignment takes you longer than about 30. So I don't know where that estimation came from, or like, I don't know, but no. So the reason I wanted to do this one with you is because there's a negative sign in front of an x squared. And again, if I am very deliberate, I realize that not all young people are going to show their work to the extent that I do, but I'm not going to be held responsible if you miss it and choose not to follow the directions. So here it goes. I'm going to write out this function rule in the purple box. And every time I get to the letter X, I'm going to put parentheses. So here it goes. Negative input squared plus 2 input plus 6. And what am I going to put in place of my inputs? I'm going to put -7 here and here. And again, I just don't think you need a calculator for this, for the record. But which part of this do I have to focus on first? The exponent part, and it's just the exponent part. So let me again draw a little cute green bubble cloud thingy around it for you. What is -7 when you square it up? Good. So what really then is the answer to this whole front part? Nice. And I mean, if I had $1 for every time someone tried to tell me that was positive because it's a negative squared, it's like, no, it's not. It's something squared with a negative put on after the fact. So nice. Yeah, so definitely -49 and then -14 and then +6. And what's -49 minus 14? Say it. Yeah, follow your heart. You have good math skills. Trust them. -63 plus 6 is -57. There I was just telling you you had good math skills and you said -54, but we're going to act like that didn't happen. So any questions about that? All right, so it's in Delta Math. It should pop up for you. I think it assigned itself automatically like 10 minutes ago. Let's see if we can get it done. I have 30 problems. They are random. So you might get 3 of one kind in a row, or it's going to scramble them up. And I gave each problem type an equal likelihood of occurring. So you get what you get. We'll leave the recording paused. So if you have any questions, something that I didn't cover, then I will unpause and explain before I finalize the video here.